Hello friends, today our topic is the multiplication of the matrices with different dimension. And different dimensions means the matrix multiplication with different orders. So far we have multiplied the matrices with the same dimensions. You can check my previous video for the matrix multiplication of 2 cross 2 and 3 cross 3. In addition, we know that the multiplying of the two matrices with the same dimension gives a matrix of the same dimensions. That means you may check once again the previous video that when we are multiplying two cross 2 matrices, the resultant matrix is also giving us the matrix which is of order 2 cross 2. And once again of the 3 cross 3 matrices, after multiplication give us the resultant matrix as 3 cross 3. So how would we know the dimensions of the computed matrix? First we need to see multiplying the matrices gives you a defined matrix. Is the matrix defined? That means is that the matrix multiplication is possible or not? There are the cases where it is not possible to multiply two matrices together. For those cases, we call the matrix to be undefined. So how can we tell if they are undefined? The product of the two matrices is only defined. Once again, the product of the two matrices is only defined if the number of columns in the first matrix is equal to the number of rows of the second matrix. The number of columns in the first matrix is equal to the number of rows in the second matrix. Let's try to use this definition in this example. Let A 1, 2, 3, 4, 5, 6 according to the row. So that is 2 cross 3, and B 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That means 3 cross 4. Is A dot B defined? First, notice that also the second matrix has 3 rows. Since they are both equal to 3, then I know that the A cross B, that means A dot B is defined. Now that we know it is defined, how would we know the dimensions of A dot B? The dimension property. To find the dimensions of A dot B, we need to first look at the dimensions of the matrices of A and B, that is separately. Let matrix A is of the order that is 2 cross 3. We know already. And matrix B is 3 cross 4. Now we are going to put the dimensions of the matrices side by side like this. So once again the matrix multiplication is possible when we have the number of column in the first matrix is equal to the number of row of the second matrix. So here that is both are 3. So matrix multiplication A dot B is possible. Then for the dimension, what we are going to do now is to take the first number and the last number and combine it to get the dimensions of A dot B. See that the first number is 2 and the last number is 4. So the dimensions of A dot B would be like that. 2 is the first one, that means the row of the first matrix and the column of the second matrix. So the resultant matrix, that means the A dot B would be 2.4 of the resultant matrix, and that is for that two matrices that must be 2 cross 4. So we can just compute each entry by using the dot products, and this will give us like that. So that is our row 1, 1, 2, 3 and row 2, 4, 5, 6 for the first matrix, that is A. And for the second matrix, that is column 1, column 2, column 3 and column 4. So we know the resultant matrix would be of order 2 cross 4. So that must be our A11, A12, A13, A14, and that one entry is A21, A22, A23 and A24. Just look at the dot product of the vectors or the row and column. R1 C1 A11, R1 C2 A12, R1 C3 A13, 1 A21, R2 C2 A22, R2 C3 A23, R2 C4 A24, and finally after calculation we are getting the result or the resultant matrix as 6, 6, 6, 6 according to the first row and 15, 15, 15, 15 according to the second row. Let's check another example. The first one matrix A is of the order 3 cross 2. That means according to the row, that is 1, 2, 3, 4, 5, 6, and B that is of the order 2 cross 4. So that is 10, 20, 30, 40 according to the row and 50, 60, 70, 80. So we have to check, that is our first row 1, that is our row 2, that is our row 3 when we are proceeding to the A dot B. And the question is A dot B defined? Is B dot A defined? Now A is of the order that is 3 cross 2, and that means when we are proceeding with the dot product A dot B, and B is of the order that is 2 cross 4. Now check that the column number or number of columns of A is 2 and the number of row of B is 2. So A dot B is possible. So what should be the order of A dot B? So that one must be 3 cross 4. So that means the row number of A and the column number of B. So the final resultant matrix would be of the order 3 cross 4. We are multiplying A dot B. So here that must be according to that the first row, first column. So that is 1 into 10 plus 2 into 50. The second one must be first row, second column, as that is our A12. So that is 1 into 20 plus 2 into 60. The third one must be A13, that means first row, third column, 1 into 30 plus 2 into 70. In the same way, 1 into 1, 2 and 40, 80. For the second one, that is A21, so that is second row, first column, 3, 4 and 10, 50. For the next 3, 4, 20, 60. Then 3, 4, 30, 70 and 3, 4, 40, 80. The last row must be in that way 5, 6 and 10, 50, 5, 20 or 5, 6 and 20, 60, 5, 6 and 30, 70, and the vectors use 5, 6 and 40, 80 for the last one. So the resultant matrix is 3 cross 4, and after the addition or the calculation we get the resultant matrix as 110, 140, 170, 200, 230, 300, 370, 440, 350, 460, 570 and 680. Let's check the B cross A is possible or not. Now B has the matrix that is with the order 2 cross 4 and A has the matrix with the order 3 cross 2. Now look at the number of column in the matrix B, that is 4, and number of row in matrix A, that is 3. So that is not equal. So B cross A or B dot product A is not possible. So B dot A is not possible as the number of column of B, that means the matrix which is in the left hand of the dot, is not equal to the matrix A. That means the matrix which is on the right hand of the dot is with of different number of row. So for matrix multiplication, the first matrix column number has to be equal with the row number of the second matrix, and that is the rule for the matrix multiplication of different dimensions or of different orders. So simply we can say, if we have a matrix A cross B, and that is M cross N, and that is N cross R, so the matrix multiplication is possible, and we have a dot matrix, or the resultant would be with the order that is M cross R.